Hello and welcome to the fourth lesson in Module 6. The fourth lesson is on natural logarithms. We will look into the learning objectives. It is to simplify expression with natural logarithms and to solve exponential equations by using natural logarithms. We will come across this natural logarithm in a while. Before that, let's see the keywords. They're natural base, exponential function, a natural logarithm. Now, natural base, natural logarithm, what is this exactly? We know in exponential form there is e, this is Euler's number. Now if a logarithmic function will have a base e, then it is that e is natural base and then it is called natural logarithm. Only thing is, now here whenever the logarithmic function will have a base e, then we get natural logarithm and we write it in a short form ln, natural logarithm. This is how we write it. And we have seen the graphing already. Now here e to the power x graph is given over here. Natural logarithm is the exact inverse of this because exponential and logarithmic functions are inverse of each other. E to the power x is inverse of ln x. Now we have done this already. We will do this now in these problems. We will just recall. How do we write this exponential in logarithmic form? Before I begin, I just want to quickly remind you, please watch the previous lessons because all this was done in detail. The graphing was done in thorough detail, and also the conversion of this logarithmic function was taught in detail in the previous videos. Now I'll quickly brush through these. Here you can see the exponential e is the base of the exponential function. Whenever you have a base of exponential function, when you move to the other side, that becomes the base of the logarithm. In the sense, whatever power comes down and this gets pushed to the other side. X equals e goes and becomes the base of log, and we have 14. Now instead of log base e, we write natural logarithm ln 14, and that is equal to x. So that is the answer. You can write ln 14 equals x or x equals ln 14. It's the same. Same way over here. This e goes to the other side and 7 comes down. 7 equals log base ex. But anymore, when we know that e is going to the other side, it's log base e, we can directly write ln. So we can directly come to this ln x equals 7. And now here we will directly write the answers. 3 is down equals ln, that is ln. You can call it ln, len, anything, you know, whatever is convenient. It's natural logarithm. If I tell ln, it's natural logarithm. Okay. So now this e goes to the other side. It becomes base log base e, which is natural logarithm 4x. Here we have 4x equals ln 3. So these are the answers over here. Now this can be written first, ln 4x equals 3, or you know, it's one and the same, it's equated. And over here we have ln 3 equals 4x. This is how we convert exponential to logarithm. Those way conversion of exponent to logarithm. Now we'll do inverse from logarithm to exponential. When we have ln, we know that is equal to log base e. Now over here 9 is there, equals x. So the base of log goes to the other side and becomes the base of the exponential function. This moves to the other side and this becomes the power. It jumps. 9 remains as it is. 9 is as it is, equals. Now this base becomes the base of exponential and to the power x. That's it. 9 equals e to the power x, or e to the power x equals 9. So this is the answer. Same way over here, you can directly write this x equals e to the power 1.7347. This goes to the power and the base of natural log is e, and that goes to the other side. So this is the answer. It's very, very simple. We have done this already in the previous lessons. We can write the answers quickly. All you need to do is take it to the other side. It'll be 3x equals e to the power 4, and we get over here 4 equals e to the power 3x. These are the answers. Please try more problems by yourselves. Now you can write this first or second, it doesn't matter. These are the answers. Now then, we will use the properties. The properties of logarithm also was done in the previous lesson, so please watch that video as well if you're getting confused over here. So now over here we know whenever something is written beside the log, that can be taken as the power. So now if I have log 8 to the power 3, this can be written as 3 log 8. Or if I have this as the question, 3 log 8, I can write it as log 8 to the power 3. So here when we have 1 by 3 natural logarithm 8, the same properties are used. 1 by 3 goes to the power of 8. So natural logarithm 8, 1 by 3rd the power minus ln 3 plus ln 9. Now, whenever we are minus, it is division, plus means multiplication. So now ln, just divide 8 1/3 by 3. Oh, by the way, before that, 8 1/3 is cube root of 8. Cube root of 8 is 2. Because we know 2 times 2 is 4, 4 times 2 is 8. So that's why, okay. Now, here what we do is we simplify this and write 2. Now, 2 divided by 3. Why? Because natural logarithm minus natural logarithm. Log minus log means it'll become, the numbers become division. That's a quotient property of logarithm. We have studied this in the properties of log. And then plus 9. Now here 2 by 3 and 9 are multiplied because that is how we simplify the product property. I'll just quickly recall. Whenever you see minus like this, ln, log remains same, only these numbers, minus means you're reducing, so you divide. Whereas now after this you see ln 9. Now to simplify ln and ln, what you have to do is 2 by 3 multiplied with 9, and this is your answer. It is 1 times 3 times 3 times 2 is ln 6. So that is how we get it. You can check your answer directly with calculator as well. What they are saying is, now if you write this as it is in the calculator, 1 by 3 natural logarithm is given by ln, the symbol 8, minus ln 3 plus ln 9 is equal to 1.791 and so on. Now this over here, ln 6 is also the same thing. Or you can also do one thing. If you forgot all the properties, if you're confused with the properties, do check your answer. And if you're getting it wrong, you can simplify this and get the answer in the calculator, write it somewhere. And now you have 4 options, right? Solve all the 4 options. They'll be in terms of ln 5, ln 6, and solve all the 4 options. Only one answer will match your the given question. So that would be your correct answer. So now if I do anything other than ln 6 here, if I take ln 5, it's different. Among the 4 options, only one will match your correct answer, and that will be your answer. So please try this by yourselves. You can do it in calculator or any other method, but I'll do it over here now. ln 7, and we have ln over here 27 to the power 1/3. It's minus here, and lastly ln 6. Now I know cube root of 27 is 3. 3 times 3 is 9. 9 times 3 is 27. So ln 7 minus ln 3 plus ln 6. Now 7 and minus 3 over here it will be division. Ln 7 by 3 plus ln 6. Now here we are plus, so it is multiplication. 7 by 3 multiplied with 6. 3 1 times, 6 2 times, you will get ln 14. Let's double check the answers. Both the answers must be true, must be the same. So I'll put this first 14 over here, and the answer is 2.639. Okay, let's try this one now. ln 7 minus 1/3 of ln 27 plus, I forgot the bracket, ln 6. It's 2.639. It's the same answer, and that's how we can check it. That's the answer, ln 49. Now we have got solving exponential equations by using natural logarithms. Now we know logarithm can be brought into exponential to the other logarithm. So we will use these properties and we'll solve. Now we have exponential here. How do we solve it? Now here we can simplify some stuff. Say for example 8 goes to the other side. Simplify it. But we need x value. It's to the power x, right? How do we do this? You can even take 2 to the other side. It will become 11. What happens is negative negative cancels, or you can take minus 2 to the other side. It will be divided by minus 2 here, minus 2 here. This cancels, and here sign cancels, and 2 becomes 11, positive 11. Now then you still have exponential x plus 3. Now recall what we had done at the beginning in this video. The base of exponential goes to the other side. Whatever is the power comes down, and this becomes natural logarithm 11, and x equals ln 11 minus 3. You can put this in calculator and find the answer. Ln 11 minus 3 is how much? Negative 0.6021. That's the final answer. Now if you're wondering what happened over here, they have found out ln 11 value. I directly did the answer right, but they have taken x plus 3 as, add 3 to that, the answer will be the thing, 2.3979, and then over here subtract this by 3, you will get this answer. Very simple, very straightforward. Also you can try directly putting this in calculator as equation. So you can try this. Minus 2 e is alpha and shift and ln, shift and ln. X is alpha x plus 3, add it with 8 equals minus 14. Shift and solve. The answer will be negative 0.621. So this is the direct answer of x. Now try this by yourselves. I'll do the written method. All the extra things must be taken. It's 26 to the other side first. E 0.25x plus 3 equals 26 minus divided by 6. Sorry, 26 divided by 6. Now here you will get a fraction, but that's fine. E 0.25x plus 3 equals 6 3s are 2 times goes 3, and over here it is 13. So it will be 13 divided by 3. Let's leave it like that, and now we will take the base to the other side. So this will be 0.25x plus 3 equals ln 13 by 3, and this 3 comes to the other side. It will be 0.25x equals ln 13 by 3 minus 3, and lastly you must divide both the sides by 0.25. X equals ln 13 by 3 minus 3 divided by 0.25. This is the answer. See, all you need to do is natural logarithm 13 divided by 3 minus 3, close the bracket, minus 3 divided by 0.25, and the answer is negative 6146, and so on. Over here it's approximated only till 10,000, right? 10,000 means how many zeros? This is 10,000. It has 4 zeros, so 4 decimal points only. 1 2 3 4. It's 5 over here, so this becomes 7. This is how we solve it. This is the written method, or directly you can just put in the calculator 6. You can pause the video and see the written method, or you can directly put in the calculator to check your answer. Shift E 0.25 alpha x plus 3 equals 26. You need to press shift and solve, you'll get the answer. Same thing. So that is the answer. Now there's few more problems over here. It's the same thing. It's just that there's no exponential. You have natural logarithm. Again, it's fine. Over here, what you do, you can easily take the 6 to the other side. It's division. 1 divided by 6. When it goes to the other side, it becomes multiplication. From the denominator, it goes to the numerator. It multiplies by 6, or multiply 6 on both the sides. You will get ln phi x, this cancels, and over here it becomes 6 times 2 is 12. Now you can take the exponent on both the sides. Now look over here. If you try shift and e to the power x, but instead of x, let's take ln, okay, and 1. This and this cancels, you're remaining only with 1. If you have, say, over here, phi will be the answer. Why? Because exponential and natural logarithm cancels, and whatever is there just remains. So this is what happens over here. Now left side, ln phi x equals 12, right? You're taking exponential on both the sides. Now here e and ln cancels, you're remaining with phi x only, e to the power 12. Now this is divided by phi, that's the answer. But now you can do e to the power 12 divided by phi. It is 32,550.96. Till 10,000, so 4 digits. So this is the answer. That's how we solve these. Please try extra problems, similar problems, or you can do this without seeing the answers. Just look at the question, write it in your book, and solve it by yourselves. You will learn better. Now we go to the real world problem, the last problem here. Let us see this. Newton's law of cooling relates the temperature of an object over time in relation to the initial temperature of the object and the temperature of its surroundings. The temperature in degree Fahrenheit of a bowl of soup over time is modeled by the function. It's given over here. This is the function where T0 is the temperature of the soup when it is taken off the heat source. Okay, see this T0 is the temperature of the soup when it's taken off the heat source, and TA is the ambient temperature of the room. T is the time in minutes, the small t. What is this ambient? Ambient means ambience, surrounding, nearby surrounding, the room, the surrounding room or the space. Now we have 3-part questions. The part A is evaluate the function, find the temperature of the soup that is initially 200 degree Fahrenheit in a room that is 72 degree Fahrenheit after 30 minutes. Okay, sorry, I read it wrong. Find the temperature of the soup that is initially 200 degree Fahrenheit. Now the initial temperature, the temperature when it was taken out, that is T0 is 200. And the ambient temperature, the room temperature in a room that is 72 degrees, that means the room temperature or the ambience temperature is 72 TA, and the time is 30. So all you're doing is substitute over here. TA is the ambient 72 plus T0 is this initial temperature 200 minus 72 again TA, e to the power minus 0.32. What is T? Time, that is 30 minutes. This equation will be given in the question. You can't do it otherwise. Only thing is you have to substitute. Now put everything in the calculator and solve. 72 plus 200 minus 72. Multiply this with e to the power minus 0.032 into 30. What is the answer? 121. So this is the answer. It is by using calculator. After 30 minutes, the soup will be about 121 degree Fahrenheit. Okay. Now then, find the temperature. Okay. Okay. Now I just want to tell you, make you understand this problem. See, the soup was initially how much? 200 degree Fahrenheit, but the room was 72 degree Fahrenheit, right? Now here what happens? There is a temperature difference. What happens when the temperature difference? Whenever there is higher temperature, it flows down to lower temperature, right? And time is after 30 minutes. So the soup is after it is taken from the heat source. Means if you're keeping in the stove, it is boiling and then you take it from there. No more heat is going on. It was 200 degree and then now you're allowing it to cool down. So there will be decrease in the temperature in 30 minutes. From 200 it comes down to 121. That is what is happening. Now here we have another same question, but the part B is to evaluate the function time t. Suppose a restaurant manager wants to make sure that the soup is at least 180 degree Fahrenheit when it is served to the customers. Okay, if the soup is initially 200 degree Fahrenheit, the T naught is 200 and the temperature of the restaurant is 72, this one. How long for the time, how long from the time the soup is taken off the heat source should the server serve the soup? Now what they are saying is, see, the initial temperature is 200 degrees of the soup and the surrounding is 72 degrees. Now how long the server must wait before serving the soup, and the soup, this T of T must be 180 degree before serving. It must be at least. Now remember, at least means I need at least 20 dirhams. X can be greater than or equal to 20 dirhams. Okay. Now if I'm writing it other way, because over here T of T is left side, I'll write this. I need at least 20 dirham means X must be greater than or equal to 20. It can't be less than that. Okay. This is the proposition. The same thing, but I've write it other side. Opening end towards X and 20 as the closed end. Same way over here. This T of T is 180. At least means it should be whatever is there, the equation must be greater than or equal to 180. It can't be less than 180, because 180 is the least amount. So you can see the least is 180. It must be more than 180. Okay. Now what is this TA? T is the ambient temperature, that is 72, plus what is T naught? T naught is 200, and here again we have minus 72, close the bracket, e to the power negative 0.032 and t. Okay, so this t must be solved. Now since it's an inequality, you can't directly solve it. We can over here by putting 180 equals 72 plus 272, and over here instead of time you need to put alpha and x unknown value, shift and solve. You'll get the answer, but now it's an inequality. Will the inequality flip or what's going to happen? So over here, let us solve it one by one in steps. Okay, this is the equation. I hope this is clear. The equation as we have written. So this was the given question equation, only that inequality is there, and now let's solve. How do you solve? Solve whatever can be solved, that is, take the 72 to the other side. 180 minus 72 is 108. 200 minus 72 is 128. E to the power negative 0.032 t. Now use logarithm. Oh wait, okay, now before that. So take this to the other side and divide. 108 divided by 128 is 0.84375. Now take not logarithm, natural logarithm. Property of natural logarithm. Take natural logarithm on both the sides. Now when you take natural logarithm on both the sides, what happens? This and this cancels. You're remaining with negative 0.032 t, and left side is ln 0.84375. Now take this to the other side. Okay, take this to the other side. What happens basically is you will have natural logarithm of 0.84375 divided by negative 0.032. What is the answer? It is 5.3. The same answer we got a while ago. But now we can tell that 5.3 must be, t must be greater than or equal to 5.3. Okay, sorry, now. Oh, I forgot an important thing. Now, can you see this negative sign? What happens when you change a negative sign to the other side? Always remember. See, T is negative, right? Anytime, let me give a simple example. I'll have 2 greater than or equal minus x. Now, whenever I have negative, this is not what I want. I want x and positive, right? So you multiply negative on both the sides, minus values on both the sides. So it becomes minus 2 and plus x. Over here minus minus cancels and here it becomes negative. But what happens to the inequality? This flips, it changes. So whenever you're dealing with the negative sign, when you move the negative sign from this unknown variable, that is t or x or a or b, the value changes, the inequality. So here if you have to take this negative to the other side, you can do it. ln 0.84375, okay, less than or equal to changes. It's not less than, it is greater than or equal to 0.032t. See, this becomes positive, but the sign changes. Now you solve it. Now it will become same thing, just that the negative sign from down it goes up. It doesn't make a difference. It's the same answer. So over here it is 5 point so on, but the answer is what? It is greater than or equal to, see, 5.3 is greater than or equal to t. That means the server should take the soup within 5.3 minutes. Now let us understand this problem in a natural sense. That says the t, I'll write it over here, t must be greater than or equal to, sorry, t, I'm writing t first, so it will be less than or equal to 5.3 minutes, right? Let us understand this, the question. Here it was told, suppose the restaurant manager wants to make sure that the soup is at least 180 Fahrenheit when it is served, if the soup is initially 200 Fahrenheit. So now imagine you have a soup in front of you which is 200 Celsius. Now obviously the surrounding temperature, sorry, not 200 Celsius, it's Fahrenheit. Now the surrounding temperature is lesser than that. Now here you must leave it, okay, but you have to make at least, it should be more than 180 degrees, okay. You will leave for 1 minute. From 200 it comes down, it might have come to 195. This from 200 195 in 1 minute. Next 1 more minute it became 190, 1 more minute 185, 1 more minute 180. So you need to take within a certain limit, right? If you tell t is greater than or equal to 5.3, this doesn't make sense. Why? Less than would mean you can even take at 1 minute, because it should be at least 180. You can even take the soup at 190. So it can be t of 1, t of 2, t of 3, 4, 5. But after 5.3, this reduces, the temperature goes less than 180. It might be 179, 178, 170. So make sure the waiter must take the soup within 5.3 minutes. If you understand this question, then you will realize why the inequality makes sense. Okay, or even if you don't understand this, just solve the problem properly. When you have to change the sign and inequality, do change it properly and you will get the correct answer. Now the last one, same question, evaluate the function T0. Okay, suppose a restaurant manager increases the temperature of the restaurant to 75 degrees. Now here TA, ambient temperature, is 75. And wants the server to have at least 7 minutes to serve the soup to the customers while the soup is 180 Fahrenheit or warmer. And what temperature will the soup have to be when it is initially taken off from the heat source? So now you will be cooking the soup and then you switch off the gas and you keep it outside. And then in a restaurant, the waiters will be running around. They'll come, they'll serve the soup and take it to the customers, right? So now the manager wants to make sure after one order is done, at least 7 minutes the waiter will have. So because he'll be busy, so 7 minutes is the time for him. But the soup must be at least 180 Fahrenheit. Okay, so this temperature, the soup temperature, must be at least 180 Fahrenheit. That was the same inequality like we had last time. Here TA, ambient temperature, is 75 plus We don't know when we should stop heating, how much must be the initial temperature, or when the gas must be switched off, or when the soup is taken off the source of heat. So this is unknown, T naught. Minus TA is 75. All the other things are known. E minus 0.032, and the time, they can at least use T of 7 minutes, multiply by 7. Here only thing is this T naught. So now over here you can again check the answer directly by substituting this. You will get the answer, making sure this is equal to, but the inequality is a problem, right? So now let us solve one by one, just like what we had solved a while ago. Make sure you take this to the other side. It becomes 105. Now you have this over here. Now what do? You have, okay, the important thing is distributive property here. You have this for this term and this term, bracket, so multiply it inside both. You will get T naught into e to the power negative 0.224. Oh, by the way, over here 0.032 times 7 is 0.224. So that's why it changed. And here negative 75 times e to the power negative 0.224. Next, what do? Here, you need to see this one is unknown. Leave it over here. This one can be easily moved to the other side. So 105, my plus minus becomes plus in the other side. Plus 75 e to the power minus 0.224. In the calculator, you will get the answer. Then here, just take this to the denominator, the right part, whichever is multiplied to T naught, take it here. Now we can put all this in the calculator together. Plus, okay, sorry, here it is shift e to the power negative 0.224. And over here up above it is plus 75 multiplied with shift and e to the power negative 0.224. What is the answer? It's 206.4. So the temperature must be 206.4 when it is taken from the heat source. So this is very important. When we reach this temperature, and then it must be greater than, at least, see, at least again. So the temperature, the soup, when it's cooked, it must at least reach the temperature of 206.4, and after that you can take it off. And then the servers will have 7 minutes to serve the soup before it goes below 180 degrees Fahrenheit. So this is how we solve this problem. That's the end, but it's not very complicated. It's just that you should know the inequalities, understand what is happening, understand the real world situation, and then you can easily solve it up, substituting everything in equation and getting the answer. Even directly in the calculator you can check for this answer. So that is about natural logarithm. It is similar to logarithm. Previously we have done graphing, changing exponential form. It is same, but it's just that we are dealing with Euler's number E. Log base E would mean natural logarithm. So that is the end of this video. That is it. If you have any doubts, please do post them in the comment section. I'll get back to you as soon as possible. Stay tuned for the next video. Bye bye guys.